if we look at the counter EMF starter, you forgive me, this is supposed to be 1 AR, 2 AR, and 3 AR. These are the 3 acceleration relays connected in parallel to the armature field, to the armature. So then, let's again look at the circuit. So, like I mentioned, you've got 1 AR here, 2 AR, 3 AR, and these are their auxiliary contacts, which are 1 AR, 2 AR, and 3 AR. Similar to the previous circuit, but this circuit operates now looking at the level of voltage. That's why it's called a counter EMF starter. If we look at, let me switch on my sketch. If we go to our sketch circuit, yes, so I can add the arrows here. So this is these are all acceleration relays. So again, if we look at the circuit, so we're going to start, the push button is pressed here. Once we press the push button, start push button, we're going to have the contactor M here get energized. Once the contactor M gets energized, it's going to close its auxiliary contacts here and here. Okay, so that closes. Once that is closed, then this opens up. So 1M opens up, ensuring that the contactor M receives a reduced current through the resistor R, which is connected in series to this contactor. Then as the voltage increases, okay, so the voltage is going to increase, and when the voltage reaches 50%, we're going to have the acceleration relay 1 AR, so that is 1 AR is going to pick up. Once 1 AR picks up, is going to close this contact 1 AR. Once that is closed, contactor 1A is going to get activated, closing its normally open contact, short circuiting out resistor 1, and therefore the current is going to flow through resistor 2, 3, and then through that contact and further down to the armature. Okay, and again, once the voltage increases, reaches, so we're talking about 50% here, so this is 50%, and then this is going to react at 75%. So at 75% of the voltage, 2AR is going to pick up. Once it picks up, it's going to close this contact. Once this is closed, contactor 2A is going to get energized, which will close its auxiliary contact 2A. Once auxiliary contact 2A is closed, we've got another high inrush current coming in, now short circuiting out resistor 2. So resistor 1 and 2 are short circuited out, and we have the current flowing through resistor 3 and through contact 2A, 1A, and all the way to the armature. Again, when the voltage reaches 90%, 90% of the voltage, we have the we've got the acceleration relay 3AR picking up. Once it picks up, it's going to close is contact 3A error, bringing on contactor 3A. Once contactor 3A is energized, it's going to close its normally open 3A contact. And finally, we have the current passing through, bypassing all the resistors through the contacts, 3A, 2A, 1A, and finally through to the armature. And that is the way this counter EMF operates. So one thing you have to remember is that it's going to operate, the acceleration relays are going to pick up at 50% of the voltage, at 75%, and at 90% of the voltage. And once all the resistances have been shorted out, the motor now increases its speed to full speed. So that's how a counter EMF circuit operates. And the next circuit is what we call a lockout acceleration starter. It's got a special lockout relay. Okay, special lockout relays. One is the holding on, and the other is the closing coil. So you've got two coils, the closing coil and the holding on coil. And what this does is that when we start the circuit, when we press the start button, we have the current flowing through, energizing the contactor M, which is going to close these auxiliary contacts M and the holding on auxiliary M. Once these are closed, let me show you with my sketch circuit. So it's very interesting. What will happen is that when the start button is pressed, we are going to have this contact close, that contact close. So the armature starts to run directly with these three resistances in series to the armature. Okay, current is going to flow in this direction, all the way in this direction. Then after a preset period of time, you've got the holding on 1AH or relay is going to drop out. When it drops out, 1AC or the closing coil will remain closed, and the current, once 1AC remains closed, once 1AH drops out, 1A closes. Thereby, the current will flow through the closed 1AC, bypassing the resistor 1 through 2AC, 2AH, and continuing through the two resistances to the armature. So resistor 2 and 3 remain in the circuit. Then again, as the armature current reduces, as the motor speeds up, you've got the holding on coil dropping out. So 2 drops out, 2AH drops out. Once this drops out, it closes the contact 2A, again forcing the current to flow through the circuit in this way, direct through 3AC, bypassing or short-circuiting resistor 2, so resistor 1 and 2 are short-circuited out through resistor 3 and continues to the armature. Again, the motor is going to increase speed. As it increases speed, the armature current starts to drop. Once the armature current drops, 3AH is going to drop out. Once it drops out, it's going to close 3A contact. And finally, the current is going to bypass all the three resistances to pass through that circuit to the armature. So all the three resistances are bypassed, current will flow direct through that line, and down through to that line. Okay, and in that way you have resistor 1, resistor 2 and resistor 3 shorted out of the circuit. Okay, I'm going to end here for this section, and like I have explained, so we've looked at the three types of current limit starters. Sorry for that. Next section, I'm going to explain to you the definite time starters, which are going to start with a mechanical timer starter. But taking you back, we've looked at the lockout acceleration starter, which is a current limit starter. We've looked at the counter EMF starter, and we've also looked at the series relay starter. And that means we've looked at the current limit acceleration starters for DC. So for this video, we are going to end here, and in the next video I'm going to explain to you what the definite time acceleration starters are about. Thank you, and please don't forget to subscribe to my channel. Thank you.